Okay, guys, welcome to our part two of our prelim in discrete structure one. So, for our part two, we'll discuss all about relation. So, whenever sets are being discussed, the relationship between the elements of the sets is the next thing that comes up. Relations may exist between objects of the same set or between objects of two or more sets. Definition and properties. A binary relation R from set X to Y is written as XRY or R open close parenthesis XY is a subset of the Cartesian product X times Y. So if the ordered pair of G is reversed, the relation also changes. So itong sinasabi natin na X times Y and the RXY, ito raw yung part ng X times Y Cartesian product, no? So this is the subset and this is the whole set. Generally, an n-ary, which means the series, relation are between sets to the series A1 to AN. It is a subset of the n-ary product A1 times the series of A until AN. The minimum cardinality of a relation R is 0 and the maximum is n squared in this case. So, a binary relation R on a single set is a subset of set A times set A. So, for the two distinct sets, A and B, having cardinalities M and N respectively, the maximum cardinality of relation R from A to B is Mn or M times N. So, remember yung ating cardinality or the Cartesian product, okay? Dinidistribute natin ang member ni A sa isa pang member ni A. That's why ang maximum natin na cardinality is n squared, which is also the same as stating m times n. So if m is the cardinality of A, the first A, and n is the cardinality of the second A, so they have the total cardinality of n times n. We go now with domain and range. If there are two sets A and B and relation R have ordered pair X and Y, then the domain of R, which is represented by dom R, is the set of X of any X where X and Y is the element of R for some Y in B. And the range of R, which is represented by run R, is the set of any Y where X and Y is an element of R for some X in A. So sa mathematics, no, sa domain, sa function, sa calculus, domain is domain always refers to the input and range always refers to the output, or domain refers to X and range always refers to Y. Okay? So, para maintindihan natin, the meaning and relationship of domain and range. Let's say, for example, we have set A equals 1, 2, 9 and B equals 1, 3, 7. No? Sa case 1, if relation R daw, remember, si R is represent the relation. No? If R is equal to, then R is equal to 1, 1, and 3, 3. So this is the X. Remember, this is the X in our stated relationship. Okay, this one, the stated relationship. So this is the X and this is the Y. Okay, so this one comes from the X. Okay, and this one comes from the Y, which is the B. Okay, so they are equal to, so we have 1, 1 and 3, 3. So meaning X and Y are always equal. So ang ating DOM R, based on this relationship, we have 1 R, sum in Y, sum in X, X is 3. Then sa range, sum in X, which is 1. And then its real value, Y is 3. So 1, 3, and 1, 3. Sa case 2 naman, if relation R is less than, then R is equal to 1, 3, okay, 1 and 3, and the X is less than. So less than meaning X is less than Y. So 1 from here, 3 from here, less than 1 again here, 7 less than again, 2, 3, 2 from here, 3 from here, 2 again, less than 7, so 7 here. So, ang relationship natin follows the less than relationship, no? So, if we have this relationship, we have domain R is equal to 1, 2, okay? From here, here, and then here, here. This is 1, this is 2, all from X. And the Y, all from Y, 3 and 7. We have 3Y here, 7 here, 3Y here, and 7Y here. So we have 3 and 7. Sa case 3 naman, if relationship R is greater than, meaning Y or X is greater than Y, so we have 2. So 2 is greater than 1, so we have 2, 1. 9 is greater than 1, so we have 9, 1. 9 is greater than 3, so we have 9, 3. And 9 is greater than 7, so we have 9, 7. And based on this, we will get the domain, which is 2 from X, 9 from X, 9 again from X, 9 again from X. From Y naman, which is the range R, we have 1 from Y, 1 from Y, so we have 1. 3 and 7 for Y, so we have 3 and 7. So these are the examples for the different cases of our binary relationship between domain and range. So representation of relations using graph. A relation can be represented using a directed graph. The number of vertices in the graph is equal to the number of elements in the set from which the relation has been defined. For each ordered pair x and y in the relation R, there will be a directed edge from the vertex. So alamin natin yung mga term na yan, kung ano ibig sabihin based sa ating graph sa baba. So we have vertex x to vertex y. If there is an ordered pair x and x, there will be self-loop on vertex x. Suppose there is a relation R 1, 1, 1, 2, 3, 2 on set S, which is equal to 1, 2, 3. It can be represented by the following graph. So we have the circle representing as the vertex and the edge represented by the line with the arrow, and the arrow represents the direction of the of the edge, no? So if we have 1, 2, 3, okay, this one will be the vertex 1, and this one is the vertex 2, and this one is the vertex 3. So paano ko nalamang ito yung 1? Kasi based on this relationship 1, 1, meaning there is a loop. Remember, if x is equal to x, then there is a self loop, meaning the edge loops, no, to itself. Okay, so the edge loops to the vertex for the case of the vertex 1. For the case of 1 and 2, this one means 1 to 2, 1 from 1, the edge goes to 2, and from 3, the edge goes to 2. Okay? So the x is always, no, away from the arrow, and 2 or the y value is always the direction of the arrow. Types of relations. Number 1, empty relation between x sets x and y, or on E is the empty set 0. So kung wala silang relationship, then their set are 0, no? The full relation between sets x and y is the set x times y, no? So ibig sabihin, lahat ng element ni x and y merong full relationship. Identity relation on set x is the set x and x if any x is an element of set x. So kapag malaking letter, alam natin na siya ay pangalan ng set, no? Kapag maliit na letter, alam natin siya ay member or element ng X. So the inverse relation R complement of a relation R is defined as R complement is equal to any BA where A and B is an element of R. Okay, so we have the inverse relationship example, no? So example 1 and 2, 2 and 3, then R complement will be 2, 1 and 3, 2. So bakit natin nasabing 2, 1 and 3, 2 is the complement of R? Because when we say complement, as we discussed from the first lesson or part 1, our complement is the reverse or the inverse of the set R, no? A relation R on set A is called reflexive if A is a set of big A and is related to A holds, no? Ibig sabihin reflexive, may binary sila and katulad ni X and X, they are equal, no? Remember yung ating X kanina, 'di ba may ganito siya? Representation X, R, binary relation yan. But in this case, the binary relation is reflexive, no? Ibig sabihin reflexive, pareho sila ng value or ng elements or laman, no? So the relation R B on set X is equal to AB and it is reflexive. A relation R in the set A is called irreflexive if no A is an element of big A and is related to A does not hold, no? So wala siyang ganitong relationship. Example, the relation RABBA on set X is equal to AB and it is irreflexive. Bakit? Because yung X and Y value niya is not equivalent, no? Hindi siya reflexive, no? Irreflexive ang tawag sa kanya. A relation R on set A is called symmetric if X R or relation Y implies Y R X. So kapag in-inverse natin, kahit baliktarin natin, the same pa rin siya, then it is symmetric, no? Ang kanilang relationship wherein X is an element of A or big A and Y is also an element of big A. So the relationship in this example is set R is equal to 1 and 2, 2 and 1, 3 and 2, and 2 and 3. So on the set, we have 1, 2, 3, and it is symmetric. Okay? Kahit baliktarin natin, there is still the same, no? Value, no? The same sets. So relation R on set A is called antisymmetric if X R Y and Y R X implies that X is equal to Y and X is an element of big A and Y is an element of big A. So, ang tawag sa kanila is antisymmetric kasi X and Y has equal value. Wherein sa symmetric, dapat si X and Y is not equal, no, in value. Like what is indicated in this example. So sa example natin ng antisymmetric, we have set R is equal to X and Y where X and Y were natural numbers or any natural number which represents X and Y wherein X is less than or equal to Y. So yung value nitong any natural number na to is will be the value of X which is either less than or equal to Y. So it is antisymmetric since X is less than or equal to Y and Y is less than or equal to X, which implies that X is equal to Y. A relation R in the set A is called transitive if X and R Y and Y R Z implies X R Z, X Y Z is an element of A. Example, the relation R is equal to 1, 2, 2, 3, and 1, 3 on set A equals 1, 2, 3 is transitive. Okay? So, we have 1, 2, we have 2, 3. and we have 1, 3. So, 1 being transferred here, and 3 transferring here, and 2 transferring there. Okay? Meaning all of the elements here can be in any position, no, within the indicated sets. A relation is an equivalence relation if it is reflexive, symmetric, and transitive. Example, the relation set R is equal to 1, 1, 2, 2, 3, 3. So, makita nyo rito na sila ay pare-pareho, no, ng laman. No? Both reflexive, symmetric, at the same time transitive. So, it is an equivalence relation since it is reflexive, symmetric, and transitive. So, these are all for the part 2 of our prelim lesson in discrete structure.